Going to page 388 in your workbooks, we have a few problems here that we skipped the other day. Let's look at this picture of this angle drawn in standard position. The initial side of the angle is pointing to the right on the positive x-axis. The terminal side of the angle is pointing toward an angle this direction in the third quadrant. We're supposed to figure out what the angle is. We could sort of guess from how it looks, but since they've actually given us some points, we should take the time to figure it out carefully, making sure that our guess is correct. I'm going to draw the terminal side of the angle only, and then I'm going to take that terminal side of the angle and turn it into a right triangle. You can see how they've marked a point on this here at 2, 2. If this point is at 2, 2, and I'm wrong because it's actually negative 2, negative 2, that indicates that on our graph we're going left 2 and then down 2. That tells us that this side of our triangle is 2 and this side of our triangle is also 2. That means that this is an isosceles right triangle. And if this is an isosceles right triangle, or half of a square, because the sides are the same length, the two legs of the triangle are the same length, that means that this angle, little angle right in here between the negative x-axis and the terminal side, has to be 45 degrees, because this is a 45, 45, 90 triangle. Now let's figure out what that means for the entire angle going this direction. Remember, we start here at 0, then 90, then 180, and we're going to go 45 degrees past 180. To find that number, we can go 180 plus 45, and that tells us that this angle is probably located at 225 degrees, if I can add correctly. Let's look at these other two problems together. This shows us needing to figure out the angle going this way. Again, we have a point at 2, 2. If we turn this into a right triangle, having that corner point at 2, 2 indicates that this side of the triangle is 2 and this side of the triangle is 2. Again, an isosceles right triangle. That means that this has to be a 45-degree angle. Is the answer to this problem 45 degrees? Well, no. 45 degrees is coterminal with the angle, but notice how they've drawn this arrow going clockwise. That means they want the negative angle that is coterminal with 45 degrees. So to find that, we're going to take negative 360 and add the angle we just found, which is 45, and that gives us negative 315 degrees. This one's a little bit different. If we turn this one into a right triangle, and if I draw it from the dot there where we know the coordinates, that's way small. So let's pretend that our dot is further this way, but that those coordinates still apply. This triangle has a point at the corner at negative square root of 3 over 2, positive 1/2. That would mean that this side of our right triangle is square root of 3 over 2, and this side of our triangle is 1/2. Well, doesn't that correspond to numbers that we just talked about with regards to a special right triangle that has a hypotenuse of 1? What would this angle have to be in order for it to have these numbers? Well, it's either a 30 or a 60. The 30-degree angle is always across from or opposite the 1/2, and the 60-degree angle will always be across from the square root of 3 over 2, or the longer leg of the triangle. So that must mean that this angle up here is 60. So the one that we really care about is down here in the corner, and that angle is 30. Let's zoom this in a little more. So we're not trying to find that 30-degree angle. We just need to use that to find the angle represented by this arrow, initial side and terminal side. 30 degrees is what's left over after we get to that angle between it and the line that is 180 degrees. So this time, in order to go back this far to that angle, we need to subtract the 30 degrees that we found in that corner angle. So 180 minus 30 degrees, or 150 degree angle.